Howdy folks, I like to investigate the approximation of pi, the number of pi, the number of times that the diameter fits in the circumference of a circle. And I'm using the Gregory-Leibniz series, in which case I took 4, that's this one, and I took 4 out of the brackets, and so it's 1 over 1, 1 over 3, 1 over 5, 1 over 7, and so on, minus, plus, minus, alternating. But I'm using a trick. I mean, this is not that quickly, but I'm using a little trick in which it goes quickly. Well, here I have these numbers, which are 2 times, well, if this is x, hope you can see all this. To elevate it a little bit, maybe. Okay, maybe a bit too much. Let's see if I have another stand on which I can put it. That's too little. Okay, well, this is 2 times a1, a2 plus 1. If you can see it over there. Okay. Can you see it? Can I see it? Can I see it so that you see it? Oh, there it is. Yeah. So that's the formula. This is x, and this is 2 times x plus 1. And you see it goes down 1, 3, 5, 7, etc. Okay. Based on that, I'm building this mathematical trick for you. I'm showing you this mathematical trick. Now, what we do is 1 over this, which is that. It's 1. And I copy that all over the place. So we get this. Then we take that one and we add is thus. Oh no, wait, I'm making a little mistake. What I have to do here is also, I forgot something. Multiply it by minus 1 to the power of x, and so on. And then copy it all over the place, because then you get the alternating 1 minus 1/3 plus 1/5 minus 1/7 and so on. And then we're going to start to add. So is here 1 plus this term, and that is slowly converging to a certain number, which we have to multiply by 4. So what I'm doing is here, take this number, 1 times 4, etc. And I'm copying this all over the place, which we can see if you do it long enough, it converges to pi. But we can do better than this and quicker than this, because this is very slow going, very slowly going to pi, very extremely slowly, even after 223 times. It's not even close to what we know as being pi. So it's a very slow process, but there's a neat trick I'm going to show you here. What I'm going to do is take this number is that number, the first result, plus the second result. Close the brackets and divide it by 2. And then copy it all over the place. We see that it already is more rapidly converging to pi. Not as fast as I like, but okay, we're just getting started. I do the same trick with these two. So this is the average of these two. This is the average of these two. This is the average of these two. This is the average of these two, and so on. So I'm taking is the average of this one plus that one. I'm dividing it by 2. And I copied it all over the place. Already here we see that it converges much faster. Now we keep repeating this process, is taking the average of that one plus that one by dividing it by 2 and copying it all over the place. Also, this is going to much faster to pi, as we can already see here. Here is already 31415. Here we have 59 already. So that's converging much faster. So we keep repeating this trick. Is brackets open, is that plus that, brackets closing, dividing by 2 and copying it all over the place. And here the same. I do it manually so you can see what I'm doing. That plus that one divided by 2, just taking the average of these two numbers and then copy it all over the place. Well, this over here we got in the digital representation or in the computer of pi over here. Over here, as the fifth mean, gemiddelde in Dutch, gemiddelde staat hier, the fifth gemiddelde, the vijfde gemiddelde, the fifth average, is this number here, over here. And I subtracted pi from it, or pi from this, or this from pi. And I'm looking at the differences. And I see, and I'm trying to see how fast it is moving towards each other, towards the optimal number of pi. And as you can see, it is way much quicker converging to a pi than if I would take it, take here 40 steps, only 40 steps in doing this, and we already are here in the last column here. We are at hydrogen nucleus size accuracy with respect to the digits of pi here. If we go further on here, let's go on further. Here already at around 200. Highlight it a little bit. We are at proton size level of accuracy. I mean, protons are about 10 to the power of minus 14, minus 15. So we are here already at the accuracy level of proton size accuracy in the 10 to the minus 14, minus 15 numbers. And that's pretty accurate. Only after, what is it, 200 steps. I mean, here you have it. After 200 steps you are at proton size, nucleus size, accuracies numbers. So it's very much quicker conversion towards pi than the normal, because the normal pi in this method is only these numbers, which are not so accurate, to be honest. But if you keep on, and I can keep averaging out over and over and over and over again, so it even gets quicker. I mean, if let's do that again. Average out one more time and see what happens. Is that plus that, closing the brackets, dividing by 2 again, is, there you go, and put it away and do the same trick here. Let's see how accurate it is compared to pi. Is pi, which is this number, yeah, minus the new found number. Okay. Make it a solid number. C1 is it? C dollar sign 1 minus that. Okay, so that it stays fixed. And copy it all over here. It's to the power of 7, which was here. You can see the difference. It's even quicker converging to here. It's the power of 6 is to the power of 6 is here, and here it's already there. And here the 7th to the 7th power accuracy, and the accuracy is getting more quickly. So now you already have atom size accuracy at, what is it? At this level, and that is 29 steps, so from 40 to 29. So averaging the results, averaging over and over again, is getting you a quicker result, accurate result. And here at 10 to the minus 14 is already at, what is it? Home at 104 steps. So it reduced a factor of 2 at comparable accuracies, nucleus size accuracies, as you can see by yourself. Let's see if again, well, there it stops. The computer cannot handle it. Well, this is a kind of Excel. It's not Excel, but it's LibreOffice. It's a free spreadsheet program. But you can see that you can very quickly converge to, well, decent, accurate numbers of pi in this method, simply by averaging the first results and keep averaging it over and over again, and so on. So that's a neat trick to converge more quickly than a regular way of doing, which is this one, this column. If you compare the columns, then you reach pi much quicker in lesser steps than if you do it the old-fashioned way. Okay, this is what I wanted to share. Thanks for watching. See you next time. Bye bye.